Hello, and the purpose of the day today is I can find the maximum and minimum and domain and range of quadratics. Finding the maximum and minimum values of quadratics. The max or the min, so maximum or minimum, is just the y value of the vertex. So let's look at the function g of x equals 2x squared minus 4x minus 1. Part A of this problem says determine if the function has a maximum or minimum. So if you can recall from last notes, we are going to look at whatever a is in front of x squared, so that the number that's in front of x squared, and if that is greater than 0, our parabola will open up and we will have a minimum. If a is less than 0, so that number in front of x squared is less than 0, our parabola will open downward and we'll have a maximum. Here it is 2, and 2 is greater than 0, so we have a parabola that opens upward. Therefore, the lowest point of this parabola here means that we have a minimum. Part B of this problem says state the max or min. So again, to find the maximum or minimum, we just want to figure out whatever the vertex is, and specifically the y-coordinate, because that tells how high or low that minimum or maximum is. So to find the vertex, again, I need to figure out for my x-coordinate the opposite of b over 2a, and then what I get for that x-coordinate, I have to plug into my equation and actually solve for y. So let's go ahead right now and let's figure out the vertex. So opposite of b over 2a. So b is really negative 4, so the opposite of negative 4 is positive 4 over 2 times a, and a is 2, and that equals 4 over 4, which is 1. So the x-coordinate of my vertex is 1. Now I have to solve to figure out the y-coordinate. So I'm going to plug that in, 1 in, whenever I see x out of my equation. So 2 times 1 squared minus 4 times 1 minus 1. And again, that equation is right there that I'm using. And 1 squared is 1, and 1 times 2 is 2. Minus 4 times 1, and 4 times 1 is 4, minus 1. So 2 minus 4 minus 1 is negative 3. So my vertex is 1, negative 3. So that minimum, state the max or the min for problem B, I have a minimum at, so we'll use the at symbol, negative 3. Last problem here of problem C says state the domain and range. So maybe it would help if I have a graph here of this parabola. And so the vertex here is, make a couple tallies here on my graph, is 1, negative 3. So if I were to graph this here, go over 1 unit, down 3, about right there. I know the y-intercept for this equation is negative 1. Again, that's a C term, so that would be right here. So I'm just making just a quick sketch, and my parabola would look something like this. Okay, so for the domain, I am going to look at all of the x values, or side to side on my graph, and I know that my parabola is going to open up forever. It's going to go upward and go on forever, again, because I have arrows here. And it's going to keep expanding and get, going to get higher and wider. And so my domain is all reals, or I could write that as saying x is between negative infinity and positive infinity. Now, for the range, I need to look at the y values, so top to bottom of my graph. And I notice that I'm going upwards forever because my arrows mean I'm continuing on. So I know y is going to go to positive infinity. But what's got to be this lowest point here? Well, we already know what it is because we found the minimum, which was the y-coordinate of the vertex, and we found that, and that was right here, which was negative 3. So negative 3 is actually the lowest our graph can be, and we just have to be greater than or equal to it because our parabola is opening upward, and we can equal negative 3 because that actually is part of our graph. That's our vertex. Now we are going to look at graphing quadratic functions, but without using a table like we had previously. So to graph quadratic functions in a slightly different way, step 1 is we are going to find the axis of symmetry, which is x equals opposite of b over 2a. Step 2 says that then we need to find the vertex. Step 3, find the y-intercept And step 4, connect those points and make a smooth curve to graph your parabola. Let's get started. So we need to graph f of x equals negative x squared plus 2x minus 3. First off, let's remind ourselves, which way is this parabola going to open, up or down? And again, that's by looking at whatever term is in front of x squared here, and that is negative 1. So since negative 1 is less than 0, our parabola will open downward. Just something good to note. So first, let's find the axis of symmetry. That again is opposite of b over 2a. So here, opposite of b, 2 is b, so opposite of b would be negative 2. So I'm going to write here, x equals negative 2 over 2 times a, which is a is negative 1, and negative 2 over negative 2 is just 1. So my axis of symmetry is at 1. I'm going to go ahead and plot that on my graph right now. Okay, now to find the vertex, again, this is opposite of b over 2a, and then to find the y-coordinate, I need to plug that in. So here I go. If I look at my equation here, I know that actually the x-coordinate of my vertex is 1. So now I'm going to plug 1 in to my original equation here and solve for y. So here I have negative times 1 squared plus 2 times 1 minus 3. So 1 squared is 1, but with a negative is negative 1, plus 2 minus 3, which is negative 2. So my vertex here is 1, negative 2, and again, I'll circle my axis of symmetry. And I'm going to go ahead and go plot my vertex on my graph right now. So I have plotted my vertex on my graph. The last portion before I can connect with the smooth curve is to find the y-intercept. So the y-intercept again is in the form of 0, comma c. And what is c here in our equation? It is negative 3. So my y-intercept is 0, negative 3. I'm going to go ahead and plot that on my graph right now. I have plotted my y-intercept in blue on my graph. And the last step is connect the points to make a smooth curve. Now we know this parabola opens downward, which is right. So when I connect my vertex with my y-intercept, the vertex should be higher than the y-intercept. And it is here on my graph. Again, the vertex is in purple. The y-intercept is in blue. So I'm going to connect with a smooth curve. So this is my y-intercept and my vertex. So I'm going to connect. Now that's half of my parabola, and again the axis of symmetry in green splits that parabola in half and both sides are symmetrical, so I'm going to do my best to mimic on the other side the shape of this parabola. And there I have my parabola for this quadratic function. Okay, now we're going to complete for practice one of the following 1 through 4. So for these, you're just going to choose one to put in your notes, is find the equation for the axis of symmetry, find the vertex, the y-intercept, and connect the points with a smooth curve, what we just did for the last problem in our notes. Again, please choose one of the following 4, and on the next slide I will post the answers for all 4. Good luck! Here are the answers for the 4 practice problems, and again you chose one to do in your notes, but go ahead and feel free to jot down any of the answers that you would like. Thanks for listening. Please check Google Classroom for your assignment. Have a great day.